Hi all, today we'll discuss Day 2 system design basic. So last time we discussed regarding the system design basic day first. So there we discussed a scope of problems, how why we are creating system design, what is high level design, what is low level design, how we will create a HLD and LLD, and what are the basics concept which need to be followed. So here the first day first which we discussed, so architectures and then utilizations consistency has consistent hashing, cap theorem, load balancing queue, caches, replications, SQL versus NoSQLs, index, proxy, and data partitions. So while we are creating the system design, we need to concentrate about these all topics, so that according to that we are designing the applications. So either we will go for the sequels, NoSQLs, we will go for the indexes, we will enable the proxy, we will create a data partitions, we will use the caches, load balancers, cap theorem, consistent hashing, and queues and all. So like that we will follow these all are the basics before understanding the system design of LLD and HLD. So already we discussed on day first, see these all, like how we will create a load balancers, where to enable this, what are the type of load balancings and all. And then there are multiple ways from this smart client, and what all are the hardware load balance, software load balance, and then this is the software load balance, means we will use proxies and all, how we will create a proxies, how we will enable this client side load balancer proxies, and server side proxies and all. And then here we discuss SQL versus NoSQLs, when to use SQL, when to use NoSQLs, what are the basics principles in this SQL and NoSQLs, what all are the difference in that, and which scenarios will go for this while we are designing the HLD LLD, where to go, and why we use key based, document based, column based, graph based, uh, NoSQLs, or either we'll go for the sequels and all. So there are multiple structures in there NoSQLs: key value pairs, document based, wide column based, graph based. So if you have different requirement in that, then we will go for these type of things. So we have Cassandra, CostDB, Redis, and then Neo4j. These all are the NoSQLs. So last till day first we discussed this all. So high level of the difference between the SQL and NoSQLs till now, we discussed this one. Now we will continue for the day two here. Reasons to use SQLDB. Why we will go for the SQLDB. So these different reasons will be there. If you are going for the ACID compliance or ACID related property which need to be followed, where we have a transaction management, transactions stores informations and all. In that cases, we will go for the column based, row and column based informations. That is called SQL. So sequels which have structures and unchanging. So in these reasons we will go for the acid. Or if you have to go for the different ways, then we have a no sequels, like you coding or searching based or big data's no limit, some things like that. In that cases we will go for the document based, no sequels based, or many are there. So depends on the requirement, we will design a no sequels or sequels database. Then here we have a third thing, that we have to consider a cap theorem. So what is a cap theorem? When to use cap theorem while we are designing the application system design. So this cap theorem means consistency, availability, and partitions tolerance. So these three parts which will be considered in the cap theorem, where we can use what all are the things is there in this consistency, ability, and partitions. So that we have to taken care about this cap theorem. So if you want details, here cap theorem details is there. So mostly it will be part of three part, this all which will be considered cap theorem. So it is mostly used to stop serving request from the outside, out of date partitions and all. So service is no longer 100% available. In that cases we will use that. And then we have next is redundancy and replications. So while we designing the applications, for that we have to do some replications, secondary server, primary servers. So how, what all are the servers, how many servers, what all are the replications which need to be create, or what will be the redundancy. So these all things which need to be taken care of the fourth part, that is part of redundancy and replication. So mostly duplicate critical data and services that will be created by this. Then the fifth one is a caching mechanism. So if you are handling this load balancings or any request from the client to server, server to client, in that cases mostly we are creating a low cache. So either we have a application server caches which will be handle the applications on server. So caches request layer will response data if we missed anything in that. So there are many ways we can use a caches. So if you are defining redis caches, so how we will use and where to create a while we use and system design, so these things. So mostly caches will happen two ways. One is the global caches and other is a distributed caches. So when to use global and when to use distributed caches, that need to be taken care, depends on the architects while we are creating a system design. In that time all the teams and architectures will be defined, and in that time we will see like either we will go for this cases or either we will go for the global cases, distributed cases and all. So these all are the cases mechanism on there. And then we have a global cases. If you are going for the global cases, what all other things there in the global cases, how we will communicate from the database, how we will connect with the connect applications and all. Then this is the uh, distributed cases. So this is a distribution cases where we can use the data based the cases and DB communications. So this policies also work on the different data structures like LIFO, FIFO, LRU, MRU, LFU, and random replacements and all. And then next we have a sharding and data partitions. So when to use sharding and data partitions? So the sharding is a mostly depends on the if we are going for this data or records based informations. In that cases we will take care about this design for the sharding and data partitions. Then here we have these all are the criteria which we have, like the criteria is while we go for the partitions we have a key based, key or hash based, others we have a list partitions, others we have a round robin partitions, then composite partitions, then common problems and setting partitions and all. So join, so these all are the partitions part. And then this is the mostly related for the indexing, this is related for the data structures or database while we are designing the applications where we have a storage, so we need to store the data or we have to maintain the transactions, we have to get the informations easily as per the customer requirements, client requirements and all. In that cases we will use indexing, so that indexings will be increase the storage overhead uh, fastest, and then well known how the database improve the speeds and all. So mostly it will be stored it will be improve the speed, so in that cases we will go for the indexes. So indexes also will be having in the database part. And then we have a proxies which have a proxies which will be enabled on this server side. So if you have multiple requests is coming from the client, then we have a proxy where proxy will be communicate with the web applications, web servers, then backend source. So instead of directly connect with the backend source, there will be proxy is a third party. There is used to balance the load and situations where we have to transfer the request and all. In that cases, we will go for the proxies. So we filter the request, log request, and others. So categorize all this request depend, and then they will route this request on the particular servers and all. And then queue. So this is the most important part of the queue. It's also part of data structures we can say. So we have to concentrate about the queue while we creating the system design. So how request will come and where to use and how much time will take, how many request is coming, so that we can define this queue as a synchronous queue or synchronous depends on the requirement. We will define this queue. So there are multiple ways to define these queues. And then consistent hashing. So consistent hashing is a technique where to find that, and then we have to process the request easily and fast test manner. So there are multiple indexing based hashing technique which will be applied. So depends on the requirement or applications or system design, we will create a consistency hashing. So how it works, so this is the way which will be work. So if you want, you can go through this all. This is the basic while we design any system design. So we need to concentrate about all the topics, why and when to use. And then this is the WebSocket. So WebSocket is also required to define this while we are communicating with the client to server. So this WebSocket handshake request is required, so we have a handshaking will be there from the client to server. So there will be handshaking request and response which will be communicating is a inter bidirectionals will be there. So there are multiple channels will be there, like bidirectional, single directional, unidirectionals, we can say. So these all are the part of WebSocket. So once we define this, we need to take care about the WebSocket term also. So this is the server sent event. WebSocket, we have a servers, multiple things are there, client server roles and all, so that we have to take in care. So this is the basic of system design. Here we will discuss all this. So what is consistent hashing, gap theorem, load balancing, queue, caches, replications, SQL, NoSQL, syntaxes, proxies, data partitions. So if you are going to define or design any system design of particular applications of the low level or high level, we need to take care of this. So mostly these terms we will use of high level design uh, terms. Yeah. Thank you.